can watch the videos from if you miss a day or something like that. Okay, so a couple of quick things about, first off, I want to acknowledge, is it frustrating having to struggle with this a little bit? Yep. But I've already heard some people say it, and I know some people still don't believe me on it, but when you figure it out on your own, are you going to understand it better than when I just lecture it to you?
Yeah.
Right? I literally heard Lexi say, then I realized this thing. Things that you realize will stick with you much longer than anything else. And I have checked by talking with the groups, every group has at least one person who has an inkling of what's going on at all times. Even if we're struggling with it. That means we need to talk with one another and you will grow and learn way more. Especially because, I've already told you this, I'm not going to be there for you when it comes to homework or when you leave this class. So you have to learn how to collaborate, right? Figure out what's being asked of you, figure out how to tackle that problem on your own or with a small group of people. I know it's different, I get that, but I promise you I've done a lot of research, I have explored it. What I'm trying to do for you, if you trust me on it, is for you good. Okay? So, all that being said, I want to look at 84,000 M plus, and we're not going to look at both of these because I know y'all got this already, is equal to 1,962,800. Couple of quick things I do want to point out though, right? What?
Don't get on my head, don't get on.
Did I mess something up?
Oh, no.
Okay. So, I think everyone eventually realized, okay, I'm going to subtract 84,000 M. Do not forget, first things first, why am I subtracting by 84,000 M?
I'm trying to get rid of it on
2A.
thing.
Okay, so I am trying to get P by itself. So notice, I'm getting rid of the thing that is furthest away from P to start. Right? So I'm trying to get rid of the thing furthest away from P to start. But why is it that I'm subtracting this thing?
To get rid of it?
So I get a 0, right? When you say get rid of, that's like a very abstract thing in math that doesn't really mean a lot of things, or actually can mean like 1,000 different things. We want to be clear with our language. We're creating a 0. Because what is 0 plus 36,000 P? But am I changing the identity of the equation right now? If I've just subtracted 84,000 P here. So I got to subtract it from the other side so that I don't change its identity so that the equations stay what? Thank you. So they stay equivalent, right? And another piece of detail in the language, what is the thing that I just used to maintain equivalency? Properties of equality. Cameron, which property of equality did we just use?
Subtract.
Is your name Cameron?
Nope, it's not.
Cameron, what is it we're using?
2A.
Yeah, the one we just used right here.
Yeah, you were wrong. The subtraction.
I don't want to know.
Subtraction property of equality. It's not a trick. We're subtracting. It's subtraction property of equality, right? Then the next step that we would take is divide by 36,000. Two things I want to talk about here on both sides. One, what property of equality would this be? Division, right? We're dividing. Notice though, right now, I've heard a lot of us say we're getting rid of 36,000. How is this getting rid of and this getting rid of the same exact thing? Because they're different, right?
Yeah.
This is why the language is important. This is also why some of us struggle at times because we use the same exact word to mean two very different things. So I get 1, right? I am creating a 1 here because I am left with 1p. And so, this is the equation I'm left with. Y'all, it is totally okay. In fact, I encourage that you leave it as a fraction. Don't make it harder than it has to be. I got an equation. Done. I know what p is equal to. Two things I want to talk about though, and I think Lexi, this is something y'all said you were struggling with. You were trying to subtract these two things, right? You can't subtract them. Why? Because the m, typically you would originally say it's because they're not like terms, right? But also remember what we're really saying here is I have 1,962,800 and I'm taking away what?
84,000. Yeah.
I'm just taking away m. How many times am I taking away m?
84.
84,000. I can't take M away from 1,962,800. So I can't subtract those two things. That's the fundamentals of what we're going to. Now I did notice Nathan had a slightly different answer.
Who did it above the 3600 by the 1962-800 thing?
Well, hold on one second.
This is great.
When Nathan tackled this problem, he worked on it like this. Instead of just doing one fraction bar and dividing by 36,000, he divided both of these things by 36,000. Did he divide both sides of the equation by 36,000? Yes, right? So I should also have this. So do you think that that's legal? Would these be equivalent? Yes. Know how multiplication has that distributive property? You know what division also has? A distributive property. Division and multiplication are just two sides of the same coin, literally. Right? If I have 5 divided by 2, isn't that the same thing as 5 times 1/2? So everything I do as division can be written with multiplication?
5 times 1/2 is the same thing as 5 divided by 2.
If you want to ask a question about that?
No, it's right. You're right.
Okay. Because literally think about it. I'm taking half of 5, which is the same thing as splitting 5 into 2. It's the same exact thing. You can do that with any multiplication, any division, right? And so that's the point, is that division also has a distributive property. Can you still leave it just like this though? Yes. Do I need you to simplify it? No. I just need you to solve for P. Okay. We good with that? Okay. So you don't have to simplify it. You totally could if you would. If you want to, I wouldn't. Because I'm not going to put more work on myself than I need to. Huh? It gives you a fraction right here? Yeah, so don't divide it. Yeah, I just wouldn't divide it at all. So if I were to solve for M, I think y'all got 1,962,800 minus 36,000 P divided by 84,000. Does that look right? Okay. So the real question comes out to be on 3A. It says the city is planning to hire 6 new workers and to use its entire budget. Which equation should be used to find out how many miles of 2-lane roads it could resurface? M equals. Because what am I trying to figure out?
How much you could resurface.
So how many miles? Miles of 2-lane road, right? Using that full context there, right? How many miles of 2-lane road? So 1,962,800 minus 36,000 P divided by 84,000. And the reason why, I want to know how many miles. So I know, this is the reasoning I would use. I know P and want M. Who said they have a question? Yes, ma'am. I mean, you could if you want to. You totally could. But remember, the whole point is, if you use this equation, you're going to substitute P in, and then you're going to have to use inverses to solve the equation, right? If you use this equation, all you have to do is substitute in and simplify. That's the point of solving for a single variable, is you can just substitute in and simplify, right? And makes your life easier in the long run. Okay. So then, finding the number of miles of 2-lane roads the city could resurface if it hires 6 new workers.
That's when we got fraction.
Yeah. And it freaked you out, didn't it? I mean, did you do it right?
We think so.
You think
We
so?
both got the same answer.
So what did we get for M?
Like the answer?
Yeah.
4,367 over 210.
Anybody get anything different, or is that what we all got? It freaks out a little bit? Now let me ask you this. When we were talking about cars and trucks earlier, can you get a fraction of a car or a fraction of a truck? No. Can you get a fraction of a mile?
Yeah.
So is it okay?
Yo.
Yeah, 100%. If I divide these two things, what do I get? What's the decimal version of this? Don't forget, you just hit Control Enter or something like that to get the decimal.
20.792.
Now, 20.7952 what?
Miles.
Miles of what?
A road, a two-lane
A
road.
2-lane road. There is context here. When you include the context, it makes a little bit more sense that it can be 20.7952 miles of 2-lane road. You can do a fraction of road. That's totally okay. And you could go even more detail. Miles of 2-lane road can be paved, I think is what it was, right? Say again. Well, can you get a part of a road? Or can you get a part of a mile of road? Could you do 20.5 miles of road? Yeah. So can we get a fraction of a road, or mile of a road? Yeah. That's totally acceptable, right? Yes, ma'am. This is for 3B, yes, ma'am. Now, I will point this out, listen up really quickly, because you could totally get an answer like this on one of the previous problems. If we had gotten 20.79 cars, can you have 0.79 cars? So what would we have to do in this case? Not restart it? Because you did all the work right? I would just have to round it down, right? I can't get a part of a car, and I can't round it up because I can't get 21 cars on there, they wouldn't fit, but I could get 20 cars on there. That's what you would do in that case, right? Math doesn't always work out beautifully and get perfect integer answers, right, Gracie?
Yes.
So we don't always get perfect integer answers, but if you know the context and say, hey, I'm dealing with cars, you could just round it down and say, okay, I can fit 20 cars on there. We good? Homework questions.
I have a lot.
Alright, so we have lesson 8 and 9. Hopefully it won't take the whole time, but if it does, it does. What you got?
Lesson 8, number 2, add number 2.
Lesson 8, number 2. So here's a linear equation in 2 variables. Solve the equation first for x and then for y. Can we do just one of those and then you do the other? Based on what we just did, does anybody have an inkling what I would need to do to start solving for x? To solve for x. Sorry, I'll wait a second for everyone to get their stuff out. This is on the lesson 8 cumulative practice problems.
Do I have that? I got
You
that.
should. I gave it to you Monday, yes sir. Lesson 6.
You have that photo?
Lesson
I'll
20.
take it.
There's lesson 9. Oh yeah, lesson 8 is on the back of the lesson 7 cumulative practice
Yeah, I
problem.
don't think I got the back, I got one, I have one side.
Did you give me lesson 7?
I had, it's right there, I was gonna turn it in, but you told me I could.
Yeah, so I'm glad I didn't take it yet. So it's on, oh, you didn't print
I
out
left the
the
back.
page, did you?
Yeah.
Okay, let me quickly print it for you.
Here's your lesson nine.
Alright, while I'm pulling it up for Gracie, any inklings of what to do from here? I heard someone start to say subtract.
Unit 2, lesson 9.
Alright, could I subtract 4y from both sides?
Oh, wait, huh?
Unit 2, lesson 9.
That's,
Yes, it both of them.
We'll get to that in a second. Just answer the question. Could we subtract 4y from both sides? Is that legal? Is that going to get us closer to x? Yes. Okay. So, yeah, we can totally subtract 4y from both sides. Okay. 4y minus 4y is 0. Have I maintained equivalency? Yes. Now, what were you going to ask though, Jada? Can you what? Could we add 31 first? Can we add 31 second? So does the order really matter? No? Could you have done it in the same step? Yeah, right? You could have done it as one single step. That's still creating a 0. I'm still using a property of equality to maintain equivalency. Remember, I think I made a note the other day that you just have to make sure that you work from what is furthest away first, right? So what is furthest away from my variable x? Well, that adding a 4y and minus 31. Now what would I need to do to solve for this x?
Then negative 41.
Yeah. Sorry, 4y. I don't know where I got 41 from. My bad. Thank you for catching me on that. Yep. Now what do I need to do to solve for x? Divide by 2. I have now solved for x, and you have all the algebraic work there, but I would probably expect you to make a small statement, which this statement could probably go for both x equals and y equals. What did we do to solve for the equation? We what? Okay, we simplified it eventually for parts of it, but there's something else.
What's the
We use the subtraction property of equality, we use the addition, and we use the division to maintain what? Okay, so I could just even say used properties of equality, and I would say maybe with inverses to create equivalent equations. That's it, right? Have you now shown me that you fully understand what you did and why you did it?
What's
Yeah.
that 2 between the 154 and the 4y?
That's the.
Just dividing or?
Oh, you see how it's in pink?
Okay, sorry, I was thinking there was an exponent there or something. I
Yeah,
was
sorry. No,
confused.
that was me dividing. I should have made it more clear. Yes, Lexi.
Why would you not add the 31 and apply it to the whole other side?
I did. Are you thinking about why didn't I add it twice?
Yeah, but I can't add just the one.
Well, it's that, and also if I add 31 here, how much did I actually add to the right hand side? I actually added 62. Did I add 62 on this side? So what I'm really doing is I am adding 131 to the right hand side. A better way to maybe understand it is this. So 2x minus 31 equals 123 minus 4y. You could also think about it like this. I add 31 and I add 31. I just went ahead and wrote it under the like term so that I could simplify it, right? But it's still adding 31 to the right hand side. It just would come, I would add those two terms. Does that explain the question?
Mm-hmm.
Okay. Any other questions? Can you what?
Like, you don't get so hungry, there's nothing left, and so you can feel it's like,
Eating your.
yeah, it feels like I'm like,
Well, is it just dividing 154 by 2? Remember, what property does division also have that multiplication has? We just talked about it. What property did I just use? I already used the division property of equality up here. I then divided both things by 2. I distributed. Division also has a distributive property, but you could have just left it as it was. Now this does simplify nicely.
that's why you want that, so we don't sit there like.
If you want to do that. Say it one more time. Well, you can divide 2 into the 4y. And you need to, if you're going to use the distributive property, you need to divide it into both terms. Okay?
Pretty ridiculous.
Any other questions? Yes, DJ.
Yeah, it's like weird, like, for
I
A,
mean,
or.
that
I
could
knew nothing from
happen.
there, but then she was all crazy.
I mean, we get decimals of almonds, right? So if you can have part of an almond, or part of a pound of almonds, can you get a part of a pound of raisins? Okay. Right? That's totally acceptable. Please notice, this number 1 right here should remind you exactly of what you did on 9.2. I'm not gonna work this one out. Look at 9.2. Use your notes. Any other questions?
You should make your notes like different colors or something, because I'm having trouble finding everything. It's like all like unit 2, and then it's like lesson 8, and there's another lesson 8, now there's 8.2, and then, no wait, there's another 8.2, and.
Yeah, you should do like homework, one color or something.
Yeah, you should have like all homework in pink, all this in green. You know,
That's
just something so I have like, I'll know what everything is, so if you're like plot homework, I'd just be like, oh, pink section, gotcha.
I mean, if you want, you could pick up notebook tabs.
But I don't know what tab they go in, because I don't even know what this like.
It
I
says
don't even-
cumulative practice problems if it's homework.
Yeah, that's the only thing I know is,
If it says cumulative practice problems, it's homework.
all the other stuff, I don't know what the other is.
All the other stuff is tasks that we've been working on. Yes, sir.
What time is
9:18.
You got a whole bunch.
Yep, over here on the student work center.
Next.
All right. Any other questions we know we want to ask from lessons 8 or 9? That clock is way off.
I know, but when it hits that 4, the bell always rings.
Okay.
So I kept that in mind.
That's how we get through today.
All right, I'll give you a second to see if you have any more questions, otherwise we're moving on. Tyler, did you have a question?
So we number 1 with the equation, are we doing
I mean, if you have 2 pounds of almonds, what could you substitute that 2 in for? A, and then it's asking you to figure out how many pounds of raisins, right?
About,
So it's substituting in, and then the biggest hint I can give you is look at what we did in 9.2. Yes, ma'am, Lexi.
okay, number 4,
Lesson 9.
okay, I guess, but I know like the idea of it, because we did it with.
I think we did some of this, we did some of this in lesson 9, we did some of this in lesson 7. V equals pi r squared h is an equation to calculate the volume of a cylinder V, where r represents the radius of the cylinder and h represents its height. Which equation allows us to easily find what? The height, okay, because it is solved for h, which means what needs to be on its own?
H.
H. Are there any answers we can immediately eliminate?
The top one.
A.
A. H is not on its own. Anything else?
D.
D. H is not on its own. But look at V equals pi r squared h. I want to solve for h. What is happening to it that I need to undo?
It's being multiplied.
It's being multiplied. What did I divide by?
That little thing.
Say it again, Jada.
Pi.
What's the answer? It's got to be C. We haven't even finished working it, but notice, you know that we're multiplying, so we have to divide. The only answer left is C. Now, you have to still justify. You need to explain what you're doing here.
We have to break it down.
You can use words. I would recommend practicing this because you'll have to do this for tests and things. But what's pi divided by pi? 1. What's anything divided by itself? What's r squared divided by r squared? So 1 times 1 is 1, 1 times h is h, and I'm left with v divided by pi r squared. Hey, there we go. And what did I use so that I know those equations are equivalent? Division what? There we go, right? I use the division property of equality so I know those equations are equivalent. They look different, but they're telling the same, not same solution because there are multiple variables there. Same what? Same thing, same story. They are telling the same story. I got what? Does that make sense now?
Because I can't. I'll tell you,
Please do not forget, I have the videos uploaded, and I'll upload this one as soon as I can, probably immediately after this class, so I don't have to do it tonight. You take advantage. Nope, those are better, buddy. Please take advantage of the videos. Please take advantage of your notes. That's why we want extra detail when we work through these tasks and we ask questions of each other. All right, work with each other to grow and to learn. Now, we've done a whole lot with equations. What have we not done yet?
Yeah, that's one.
Inequalities. We got to do some inequalities. A lot of the ideas that you learned with equations are exactly the same with inequalities. I need to see you get that. Okay. So, we will not spend forever on inequalities. There's only one difference between inequalities and equations. Actually, there's two differences. It's how we write our solution sets, and then one of the properties is different. That's it. So, let's take a few minutes. We won't get super far into this, but we should be able to at least get started. So, for the sake of time, we want to be able to analyze the structure of an inequality in one variable to help us determine if the solution is greater or less than the solution to the related equation. That might sound really odd. It will make sense when we start working through it. But we're going to directly compare inequalities to equations is a big thing I want you to understand there. And then we're going to write and solve inequalities to answer questions about a situation. Most of what we've done, I hope you've noticed, is work with these equations in a real world context, because math without the real world is dumb. The whole point of math is to make sense of and explain the real world. So,
Well, why we gotta explain it like this?
huh?
Never mind.
Why do we have to explain it like I'm forcing you to explain it?
No, like this is just the worst way they could have done it. Like out of all the things they gotta explain, this is what they chose. It's like, I don't know, I feel like it's like pointing out really obvious things, but then they just had to make them complicated for no good reason. Like instead of saying like, you got 4 trees, so instead of 1, 2, 3, 4, we're just gonna do 1 times 4. They had to make it like,
Well, I see what you're saying. Don't forget, the whole point of the variable is to represent different situations. If you have a cargo ship, right, and you want to load that cargo ship with as many cars and as many trucks as possible, you can have lots of different combinations. And so that's why we want variables, is to figure out which combinations are actually valid. And so you don't want, because you want to use up all the space you have so you can make the most money possible. And so it's not like we're just trying to make life harder. We're representing situations where there's more than one option. The same thing is going to be true here. I will go ahead and tell you, equations, I like them, but at the same time, they're not nearly as useful as inequalities. Because realistically, are you going to use all $1,962,800? No. So really what we should have said here was that it was less than or equal to $1,962,800 because I can't spend over it, but I can spend less than it. Inequalities are way more useful, and so that's why we're going to look at that now. So, Kyron, what do y'all think that's supposed to be? Kieran is getting dinner for his drama club on the evening of their final rehearsal. The budget for dinner is $60. Stop right there. Anyone know what we're going to do in respect to that 60?
Divide.
We might be adding, we might be subtracting,
Divide.
we might be dividing.
Like
Okay,
divide to be
if-
less than,
Say that one more time.
has to be less than 60.
It's got to be less than 60. Or could it equal?
Yes.
Yes. So notice, as soon as I see, hey, I have a budget here, I know I can't go over it. I have no clue what's going to happen up to that point, but I know that it's got to be less than or equal to 60. I haven't even read the rest of the question yet, but it's a budget. I got to be less than it or equal to it. Kieran plans to buy some prepared dishes from a supermarket. The prepared dishes are sold by the pound at $5.29 a pound. He also plans to buy 2 large bottles of sparkling water. That joker should have picked sweet tea or lemonade, but whatever. At $2.49 each. So what could I do that's going to be less than or equal to 60?
okay, 249 times 2.
Notice, is there a variable in that expression? No. Why did you multiply though?
Because there's 2 of them, and I'm going to add them.
So, yeah, so we are repeatedly what? Adding, right? Notice, like, we want to recognize, like, I didn't want to add them, so I multiplied instead, because we're still repeatedly adding. Yeah?
14, who you at? Who is it?
Is there anything else that needs to go with that 2 times 2.49?
No.
Yeah, does anything else go with that 2.49, or 2 times 2.49?
Can we do with 1.29?
I guess I should, so,
Can we do a peak if we don't have any pounded?
what do y'all think? So, hold on one second,
Can we just
5.2.
add those already, like, well, we got that.
It's a great question. Raise your hand, or give me a thumbs up if you think we could do plus 5.29p. KJ says yes, Lexi says yes, DJ says yes, Nathan, Gracie, Jada, Ashton. Grayson doesn't want to participate. You're not sure? Alright. Explain to me why you said 5.29p. We don't know how many pounds of food he bought, so why did you do 5.29p? Are we repeatedly adding 5.29 every pound?
Yo.
So can we multiply those things? Does that make sense? You sure? You give me the eyes of like, no, Mr. Kinney, so say it. So like, notice right here, we're multiplying. So ignore the water. If we're talking about the pounds of food, every pound of food costs how much? 5.29, right? So if I buy 1 pound of food, it's 5.29. If I buy a second pound of food, it's 5.29. A third pound of food is 5.29. So I'm repeatedly adding, right? And I add those two things. Now, Gracie, did you ask if we could just go ahead and add those two things?
Yeah, the 2 times the 249, like just go ahead and.
So
make
can I go ahead and
five,
multiply
yeah,
those?
that, yeah.
Now, can I add the 529 to it? No, right, so you could add, you could multiply there. So that's what we'll pick up tomorrow. Hopefully that helped us get a little bit started on it. We'll talk more about it tomorrow. In closing, all right, tomorrow, apparently we're not going to finish reviewing one variable inequalities. Apparently we're going to really start one variable inequalities, and then we're going to work on lesson 8 and 9 homework are due tomorrow. Lesson 20 is due on Monday. So we got to get rocking and rolling tomorrow so we can get there. Say again. Lessons 6 and 7 cumulative practice problems. Yes, ma'am. Say again. To us? I don't remember anything being said.